Question 1. The risk matrix shows a high likelihood of unauthorized access to sensitive customer data within a virtual private routed network, VPRN, implementation due to misconfigured access control lists, ACL. Which of the following actions best addresses this identified risk while adhering to professional network security and data protection principles? Option A. Document the identified risk in the risk matrix and schedule a review of the ACLs for the next quarterly security audit without immediate corrective action. Option B. Focus solely on strengthening the external firewall rules of the network, assuming that internal VPRN traffic is inherently secure once it enters the perimeter. Option C. Temporarily disable all ACLs within the VPRN to immediately restore full network connectivity and address user complaints, with a plan to review them later. Option D. Conduct a comprehensive review of all VPRN ACLs, comparing them against established security policies and best practices for VPRN segmentation, and implement necessary corrective actions to enforce granular access control. Correct answer is D. Conduct a comprehensive review of all VPRN ACLs, comparing them against established security policies and best practices for VPRN segmentation, and implement necessary corrective actions to enforce granular access control. Explanation. The risk matrix shows a high likelihood of unauthorized access to sensitive customer data within a virtual private routed network, VPRN, implementation due to misconfigured access control lists, ACL. This scenario is professionally challenging because it requires a network engineer to balance the immediate need for network functionality and performance with the critical requirement of data security and regulatory compliance. The pressure to restore services quickly can lead to shortcuts that compromise security. The correct approach represents best professional practice because it prioritizes a systematic and documented security remediation process. This involves a thorough review of the ACL configurations against established security policies and best practices for VPRN security, as defined by relevant industry standards and potentially internal organizational security mandates. Implementing granular access controls and regularly auditing them ensures that only authorized traffic can traverse the VPRN, directly addressing the identified risk. This proactive and meticulous approach aligns with the principle of security by design and demonstrates due diligence in protecting customer data, which is a fundamental ethical and professional obligation. An incorrect approach that involves simply disabling security features to restore connectivity fails to address the root cause of the vulnerability and introduces significant security risks. This is a regulatory failure, as it violates the implicit or explicit requirements for data protection and network security, mandated by general data protection regulations and cybersecurity frameworks. Ethically, it represents negligence by knowingly exposing sensitive data to unauthorized access. Another incorrect approach, which is to rely solely on perimeter security without examining internal VPRN ACLs, is also professionally unacceptable. While perimeter security is important, VPRN are designed to extend secure private networks over public infrastructure, making internal segmentation and access control paramount. Ignoring the internal ACLs means the high-risk vulnerability remains unaddressed, leading to potential data breaches and non-compliance with security standards that emphasize defense in depth. This constitutes a failure to implement appropriate technical and organizational measures for data security. A further incorrect approach, such as documenting the risk and deferring remediation indefinitely, is a clear abdication of professional responsibility. While risk assessment is a crucial step, inaction in the face of a high likelihood, high-impact risk is a severe ethical and professional failing. It demonstrates a lack of commitment to security and compliance, potentially leading to severe consequences for the organization and its customers. Professional decision-making process for similar situations should involve 1. Immediate risk assessment and containment, if possible without compromising security further. 2. Thorough investigation to identify the root cause. 3. Development and implementation of a remediation plan that addresses the root cause and adheres to security policies. 4. Verification of the fix and retesting. 5. Documentation of the entire process, including lessons learned. This structured approach ensures that both operational requirements and security/compliance obligations are met. Question 2. Market research demonstrates that enterprises are increasingly seeking secure and performant solutions for their private network connectivity over shared infrastructure. Considering the Alcatel Lucent Virtual Private Routed Networks (VRPN) framework as defined by the 4A0-106 syllabus, which of the following approaches best balances scalability, security, and quality of service for a large-scale enterprise deployment requiring robust traffic isolation and performance guarantees? Option A. Deploying numerous site-to-site ISEC tunnels across the public internet, relying solely on strong encryption for security without specific traffic management. Option B. Implementing a combination of MPLS Layer 3 VPNs with traffic engineering and quality of service (QoS) policies to prioritize critical application traffic and ensure predictable performance. Option C. Utilizing generic routing encapsulation (GRE) tunnels without any additional security measures or quality of service (QoS) configurations. Option D. Establishing a series of Layer 2 VPN circuits between all enterprise sites, assuming all traffic can be managed at the data link layer. Correct answer is B. Implementing a combination of MPLS Layer 3 VPNs with traffic engineering and quality of service (QoS) policies to prioritize critical application traffic and ensure predictable performance. Explanation: this scenario presents a professional challenge in selecting the most appropriate method for implementing a virtual private routed network (VRPN) solution within the Alcatel Lucent ecosystem, specifically adhering to the principles outlined in the 4A0-106 syllabus. The challenge lies in understanding the nuanced differences between various VRPN technologies and their implications for network performance, security, and manageability, all while ensuring compliance with the implicit regulatory and best practice standards governing enterprise network deployments. Careful judgment is required to balance technical capabilities with operational requirements and potential future scalability. The correct approach, focusing on a solution that leverages MPLS VPN technology with appropriate traffic engineering and QoS mechanisms, represents best professional practice because it directly aligns with the capabilities and design principles emphasized in the 4A0-106 curriculum. MPLS VPNs offer a robust, scalable, and secure method for creating private networks over a shared infrastructure, providing the necessary isolation and performance guarantees. The inclusion of traffic engineering and QoS ensures that critical traffic receives preferential treatment, meeting the stringent performance demands of modern enterprise applications. This approach is ethically sound as it prioritizes the reliable and secure delivery of services to the end users, fulfilling the network provider's obligation. An incorrect approach that relies solely on ISEC tunnels, without considering the overhead and scalability limitations for a large enterprise, would be professionally unacceptable. ISEC, while providing strong encryption, can introduce significant processing overhead and complexity when deployed at scale for numerous site-to-site connections, potentially impacting performance and increasing management burden. This could lead to a failure to meet service level agreements, SLAs, and a suboptimal user experience, representing a failure to exercise due diligence in network design. Another incorrect approach, such as implementing GRE tunnels without any encryption or QoS, would be a significant regulatory and ethical failure. GRE tunnels offer simplicity but lack inherent security, exposing sensitive enterprise data to interception on the public internet. Furthermore, the absence of QoS would mean that all traffic is treated equally, leading to unpredictable performance for critical applications and a potential violation of service commitments. This demonstrates a disregard for data confidentiality and service integrity. A final incorrect approach, opting for a basic Layer 2 VPN solution without considering the routing requirements of the enterprise, would also be professionally unsound. While Layer 2 VPNs can provide connectivity, they do not inherently support the routing flexibility and scalability required for complex routed networks, potentially limiting the enterprise's ability to grow and adapt its network infrastructure. This could lead to a network design that is not future-proof and fails to meet evolving business needs. The professional decision-making process for similar situations should involve a thorough assessment of the enterprise's specific requirements, including traffic patterns, security mandates, performance expectations, and scalability needs. This should be followed by an evaluation of available VRPN technologies against these requirements, considering their strengths, weaknesses, and alignment with established best practices, and the knowledge base provided by relevant training materials like the 4A0-106 syllabus. A comparative analysis, weighing the technical merits, operational implications, and cost-effectiveness of each viable option, is crucial before making a final recommendation. Question 3. The performance metrics show a consistent increase in packet loss and latency for a specific customer's VPRN service. Upon initial investigation, the core network's IGP adjacencies appear stable, and the MPLS LDP sessions are up. However, the customer is reporting degraded application performance. Which of the following diagnostic steps is the most appropriate next action to isolate the VPRN-specific issue? Option A. Focus solely on the physical layer connectivity of the customer's access circuits, assuming the VPRN configuration is likely correct given the stable core. Option B. Verify the status of BGP VPNv4/VPNv6 sessions between the provider edge, P, routers serving the customer, and examine the VRF route tables on these PE routers for correct route propagation and reachability. Option C. Initiate a full network sweep to check all IGP link states and re-establish all LDP sessions across the entire network to ensure underlying transport stability. Option D. Immediately reconfigure the VPRN interfaces on the PE routers to a different MTU size to rule out potential fragmentation issues. The correct answer is B. Verify the status of BGP VPNv4/VPNv6 sessions between the provider edge, P routers serving the customer, and examine the VRF route tables on these PE routers for correct route propagation and reachability. Explanation. The performance metrics show a significant increase in latency and packet loss on a specific virtual private routed network, VPRN service, impacting critical business operations for a key customer. The challenge lies in accurately diagnosing the root cause within a complex, multi-vendor VPRN environment, adhering to the Alcatel Lucent Virtual Private Routed Networks 4A0-106 syllabus, which emphasizes understanding the interplay of routing protocols, MPLS forwarding, and VPRN-specific mechanisms. Professionals must balance the urgency of service restoration with the need for meticulous troubleshooting to avoid misdiagnosis and further service degradation. The correct approach involves a systematic, layered troubleshooting methodology aligned with VPRN architecture principles. This includes verifying the integrity of the underlying MPLS infrastructure, e.g., LDP IGP adjacencies, examining the VPRN control plane, e.g., BGP VPNv4/VPNv6 peering, VRF route exchange, and inspecting the data plane forwarding within the relevant VRFs. Specifically, analyzing VPRN interface status, VRF routing tables, and MPLS forwarding tables, LFIB, for the affected customer is paramount. This methodical examination ensures that the issue is isolated to the VPRN service itself or its interaction with the core network, rather than a misconfiguration or failure in a different network segment. This aligns with best practices for network troubleshooting, prioritizing the most probable causes based on the observed symptoms and the VPRN service model. An incorrect approach would be to immediately assume a core network routing issue without first validating the VPRN-specific configurations and states. For instance, solely focusing on IGP metrics without checking VRF route propagation via BGP VPNv4/VPNv6 would be a failure to adhere to the VPRN troubleshooting model. Another incorrect approach would be to restart VPRN interfaces or VRF processes without a clear understanding of the potential impact on control plane convergence and customer traffic, potentially leading to extended outages. Furthermore, making broad configuration changes across the network without isolating the problem to the specific VPRN service or its associated network elements would be a significant regulatory and ethical failure, as it risks impacting other services and customers. Such actions demonstrate a lack of disciplined problem-solving and a disregard for the potential consequences of unvalidated interventions. Professionals should employ a structured decision-making process that begins with gathering comprehensive symptoms, consulting network documentation, and then systematically testing hypotheses based on the VPRN architecture. This involves leveraging diagnostic tools to examine the control plane and data plane states relevant to the VPRN service. When faced with complex issues, collaboration with other network teams, e. G. Core routing. MPLS transport is crucial, but the initial focus must remain on the VPRN domain as defined by the 4A0-106 syllabus. Question 4. Compliance review shows that a newly deployed virtual private routed network, VPRN, is experiencing intermittent connectivity issues and performance degradation for specific traffic flows. The implementation team has provided a high-level overview of the configuration, highlighting the use of standard IP routing protocols between sites. Based on the principles and technical scope expected for the 4A0-106 Alcatel Lucent Virtual Private Routed Network certification, what is the most critical aspect to scrutinize to identify the root cause of these issues? Option A. The overall network topology and the physical cabling between sites to rule out basic infrastructure faults. Option B. The implementation of advanced traffic shaping and policing mechanisms across all network interfaces, regardless of VPRN service requirements. Option C. The precise configuration of VPRN-specific routing instances, VRF definitions, and the correct association of interfaces with these instances to ensure traffic isolation and private routing. Option D. The utilization of the latest firmware version on all Alcatel Lucent network devices, assuming this will automatically resolve any configuration discrepancies. The correct answer is C. The precise configuration of VPRN-specific routing instances, VRF definitions, and the correct association of interfaces with these instances to ensure traffic isolation and private routing. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of implementing and verifying virtual private routed networks, VRPN, in a regulated environment. The core difficulty lies in ensuring that the VPRN configuration strictly adheres to the defined service level agreements, SLAs, and the specific requirements of the 4A0-106 Alcatel Lucent Virtual Private Routed Network syllabus, which implicitly governs the expected operational standards. Misinterpreting or overlooking specific configuration parameters can lead to service degradation, security vulnerability, or noncompliance with the intended network design, all of which have significant operational and potentially regulatory implications. The need for precise adherence to the syllabus's technical scope, without introducing extraneous or noncompliant features, is paramount. Correct approach analysis. The correct approach involves a meticulous verification of the VPRN configuration against the established design specifications and the technical parameters outlined within the 4A0-106 syllabus. This includes confirming that all necessary routing protocols are correctly configured for intersite connectivity, that the appropriate encapsulation methods are employed for traffic isolation, and that the quality of service, QoS policies, are accurately implemented to meet the agreed-upon SLAs. This approach represents best professional practice because it directly addresses the technical requirements of VPRN implementation as dictated by the syllabus, ensuring that the deployed solution is both functional and compliant with the expected standards of a virtual private routed network. It prioritizes accuracy and adherence to the defined technical scope, minimizing the risk of operational issues and ensuring the integrity of the private network. Incorrect approaches analysis. An incorrect approach would be to assume that a basic IP connectivity configuration is sufficient for a VPRN. This fails to acknowledge the specific requirements of VPRN technology, such as the need for traffic isolation and the establishment of private routing domains, which are fundamental concepts covered in the 4A0-106 syllabus. Such an approach would lead to a network that is not truly private and may expose sensitive data to unauthorized access, a significant ethical and operational failure. Another incorrect approach would be to implement advanced routing features not explicitly covered or implied by the 4A0-106 syllabus for VPRN deployment, such as complex BGP route manipulation or extensive MPLS VPN extensions, beyond the scope of basic VPRN functionality. While these features might enhance routing capabilities in other contexts, their inclusion without justification within the VPRN context, as defined by the syllabus, introduces unnecessary complexity and potential points of failure. This deviates from the principle of implementing solutions that are fit for purpose and aligned with the learning objectives of the specified certification, potentially leading to misconfigurations and operational instability. A further incorrect approach would be to overlook the verification of CoS parameters. VPRN are often deployed to provide differentiated services, and failure to configure and verify CoS policies means that the network may not meet the performance expectations of the private service, leading to service-level agreement breaches. This is a failure to deliver the promised service quality, impacting the business operations that rely on the VPRN. Professional reasoning. Professionals should approach VPRN implementation by first thoroughly understanding the specific requirements of the VPRN, as defined by the project scope, and the technical constraints and objectives of the relevant certification syllabus, in this case, 4A0-106. This involves a detailed review of the design documentation and a clear understanding of the expected traffic flows and service levels. The implementation should then proceed with a focus on configuring only the necessary components and protocols that directly support the VPRN functionality as outlined in the syllabus. Crucially, a comprehensive verification and testing phase is essential to confirm that the deployed VPRN meets all functional, performance, and security requirements before it is put into production. This systematic and evidence-based approach ensures that the deployed solution is robust, compliant, and meets the intended business objectives. Question 5. System analysis indicates a service provider is planning to offer virtual private routed network (VPN) services to multiple enterprise customers over a shared Alcatel Lucent core network. The primary objective is to ensure strict traffic isolation between these customers, preventing any inter-customer data leakage, while also providing flexibility for different customer connectivity needs. Considering the capabilities of Alcatel Lucent's VPN solutions, which approach best addresses these requirements for a diverse customer base? Option A. Configure basic IP routing across the core network without any specific VPN technologies, expecting customers to manage their own internal segmentation. Option B. Deploy individual ISEC tunnels between the customer edge devices of each enterprise, relying solely on encryption for traffic separation. Option C. Utilize a single, large VRF instance for all customers, assuming that standard IP routing will inherently prevent inter-customer traffic flow. Option D. Implement a comprehensive solution utilizing MPLS Layer 3 VPNs with VRF instances for routing isolation, and where required by specific customer applications, MPLS Layer 2 VPN e.g. VPLS for Layer 2 adjacency. The correct answer is D. Implement a comprehensive solution utilizing MPLS Layer 3 VPNs with VRF instances for routing isolation, and where required by specific customer applications, MPLS Layer 2 VPN e.g. VPLS for Layer 2 adjacency. Explanation. Scenario analysis. This scenario presents a professional challenge in network design and implementation, where a service provider must ensure the secure and efficient isolation of customer traffic within a shared infrastructure. The core difficulty lies in balancing the need for robust traffic separation with the operational complexities and potential performance implications of different VPN technologies. Misjudging the appropriate VPN approach can lead to security breaches, service degradation, or non-compliance with customer service level agreements, SLAs, all of which carry significant financial and reputational risks. Need for a deep understanding of the Alcatel Lucent Virtual Private Routed Networks 4A0-106 syllabus, specifically regarding VPN technologies and their application in a service provider context, is paramount. Correct approach analysis. The correct approach involves leveraging a combination of MPLS VPNs, specifically virtual routing and forwarding, VRF instances, and potentially Layer 2 VPNs, e.g. VPLS, where appropriate for specific customer requirements. MPLS VPNs provide strong traffic isolation by maintaining separate routing tables for each customer via VRFs and encapsulating traffic within the provider's core network. This ensures that customer A's traffic cannot be seen or routed by customer B, even if they share the same physical infrastructure. The use of VRFs is a fundamental mechanism for achieving this isolation at Layer 3. For customers requiring Layer 2 adjacency across the provider network, VPLS offers a scalable solution that emulates a shared Ethernet switch, providing Layer 2 VPN services. This approach aligns with best practices for service providers aiming to offer secure, scalable, and flexible VPN services, adhering to the principles of network segmentation and customer isolation, as implicitly expected by regulatory frameworks governing telecommunication services and data privacy. Incorrect approaches analysis. One incorrect approach would be to rely solely on basic IP routing without any form of VPN segmentation. This would fail to provide any traffic isolation between customers, creating a significant security risk and violating the fundamental principle of a private network. Such an approach would be a direct contravention of the implicit requirements for secure customer traffic handling in any regulated telecommunications environment. Another incorrect approach would be to implement a large number of individual Layer 3 VPNs using traditional ISEC tunnels between customer edge devices. While ISEC provides encryption, managing a vast number of point-to-point tunnels becomes operationally unmanageable, lacks scalability, and does not efficiently utilize the provider's core network. This approach would also likely lead to performance bottlenecks and increased complexity, failing to meet the service provider's need for efficient resource utilization and service delivery. A third incorrect approach would be to assume that all customers require the same type of VPN service and to standardize on a single technology without considering diverse customer needs. For instance, forcing a Layer 3 VPN solution onto a customer that requires Layer 2 adjacency for specific applications would lead to service failure and non-compliance with their requirements. This demonstrates a lack of understanding of the different VPN service models and their applicability, leading to poor service design and potential contractual breaches. Professional reasoning. Professionals should approach this challenge by first understanding the diverse requirements of potential customers. This involves identifying whether customers need Layer 3 routing isolation, Layer 2 adjacency, or a combination. The next step is to map these requirements to the capabilities of the Alcatel Lucent platform, specifically focusing on MPLS VPN features like VRFs and Layer 2 VPN technologies. A thorough assessment of scalability, security, operational manageability, and cost-effectiveness for each potential solution is crucial. Professionals must then select the most appropriate technology or combination of technologies that meets the defined customer needs, while adhering to industry best practices for network segmentation and security. This decision-making process should be guided by the principles of providing reliable, secure, and efficient services, ensuring compliance with any relevant telecommunications regulations or data protection laws. Question 6. The risk matrix shows a critical vulnerability in the VPRN signaling protocol implementation that could allow unauthorized access to customer traffic. The current network is operational and serving multiple enterprise customers. What is the most appropriate immediate course of action to mitigate this risk while adhering to best practices for VPRN management? Option A. Initiate a full rollback of the VPRN configuration to the last known stable state without assessing the impact on active customer sessions. Option B. Continue normal operations, assuming the vulnerability is unlikely to be exploited in this specific network environment. Option C. Immediately disable the specific VPRN signaling feature identified as vulnerable, while simultaneously initiating a planned upgrade to a patched software version. Option D. Implement a hastily developed, unverified workaround on the affected network devices to block the vulnerability. The correct answer is C. Immediately disable the specific VPRN signaling feature identified as vulnerable, while simultaneously initiating a planned upgrade to a patched software version. Explanation. Scenario analysis. This scenario presents a professional challenge in network design and implementation, where a critical security vulnerability has been identified post-deployment. The challenge lies in balancing the immediate need to mitigate the risk with the operational impact of the proposed solution, all while adhering to the strict regulatory framework governing virtual private routed networks, VPRN, as defined by the 4A0-106 Alcatel Lucent Virtual Private Routed Network syllabus. The pressure to restore service quickly can lead to hasty decisions that might overlook long-term implications or compliance requirements. Careful judgment is required to select a solution that is both effective and compliant. Correct approach analysis. The correct approach involves a phased remediation strategy that prioritizes the most critical vulnerabilities while planning for a more comprehensive update. This aligns with best professional practices by acknowledging the immediate threat and implementing a targeted fix, such as disabling the vulnerable feature or applying a hotfix if available and tested. Simultaneously, it demonstrates foresight by scheduling a full software upgrade to address the root cause and prevent recurrence. This approach is justifiable under the regulatory framework because it demonstrates due diligence in risk management and proactive security posture. It minimizes disruption while ensuring eventual compliance with security standards inherent in VPRN deployments, which are implicitly governed by the need for secure and reliable private network services. The focus is on a controlled and documented process, essential for audit trails and compliance reporting, and correct approaches analysis. Ignoring the vulnerability and continuing with normal operations represents a significant regulatory and ethical failure. It directly contravenes the implicit requirement for network operators to maintain secure and reliable services, which is a cornerstone of VPRN deployment. This inaction could lead to data breaches, service disruptions, and reputational damage, all of which have severe compliance implications. Implementing a quick, untested workaround without proper validation or documentation is also professionally unacceptable. While seemingly addressing the immediate issue, it introduces the risk of unforeseen side effects, service instability, or even new vulnerabilities. This approach lacks the rigor expected in a regulated environment and fails to establish a clear audit trail, making it difficult to demonstrate compliance during an audit. It also bypasses established change management processes, which are crucial for maintaining network integrity and security. Rolling back the entire VPRN configuration to a previous stable state without a thorough impact assessment is another flawed approach. While it might remove the vulnerability, it could also revert critical configurations, leading to significant service disruption for all connected customers. This demonstrates a lack of understanding of the interconnectedness of network components and the potential cascading effects of drastic changes. It fails to apply a principle of least impact and could be seen as an unprofessional overreaction, potentially violating service-level agreements, SLAs, and demonstrating poor operational discipline. Professional reasoning. Professionals should approach such situations by first conducting a thorough risk assessment, understanding the exploitability and impact of the vulnerability. This should be followed by an impact analysis of potential remediation strategies, considering operational continuity, customer impact, and compliance requirements. A phased approach, prioritizing immediate mitigation while planning for long-term solutions, is generally the most prudent. Documentation of all steps taken, including risk assessments, decision-making processes, and remediation actions, is paramount for demonstrating due diligence and compliance. Engaging with vendors for validated patches and following established change management procedures are also critical components of professional network management. Question 7. Risk assessment procedures indicate that a telecommunications provider is planning to deploy a virtual private routed network, VPRN service, for multiple enterprise customers. The primary technical objective is to ensure complete traffic isolation and security between these distinct customer networks, preventing any inter-customer data leakage or unauthorized access. Given the regulatory framework governing telecommunications services, which approach to VPRN implementation best satisfies both the technical requirements for isolation and the regulatory obligations for data privacy and network security. Option A. Implement the VPRN service using separate VLAN on shared network infrastructure, without VRF segregation at the PE router level, relying on basic port security. Option B. Implement the VPRN service by configuring all customer traffic within a single VRF on the PE routers, using only access control lists, ACL, to differentiate between customer traffic. Option C. Implement the VPRN service by configuring separate virtual routing and forwarding, VRF, instances on the provider edge P routers, with each customer's traffic logically segmented into its own VRF. Option D. Implement the VPRN service by assigning unique IP address spaces to each customer, but allowing them to share the same routing table on the PE routers. The correct answer is C. Implement the VPRN service by configuring separate virtual routing and forwarding, VRF, instances on the provider edge P routers, with each customer's traffic logically segmented into its own VRF. Explanation. Scenario analysis. This scenario presents a professional challenge related to the implementation of a virtual private routed network, VPRN service within a regulated telecommunications environment. The core challenge lies in balancing the technical requirements of the VPRN service, specifically the need for robust traffic isolation and security, with the regulatory obligations concerning data privacy and network resilience. The service provider must ensure that the VPRN implementation adheres to the principles of least privilege and secure network design, as mandated by telecommunications regulations, while also guaranteeing the availability and integrity of customer data. Failure to adequately address these aspects can lead to regulatory noncompliance, security breaches, and loss of customer trust. Correct approach analysis. The correct approach involves implementing a VPRN solution that leverages provider edge P router interfaces and virtual routing and forwarding (VRF) instances to logically segment customer traffic. Each customer's traffic is confined to its own VRF, ensuring that data from one customer cannot be inadvertently accessed or influenced by another. This isolation is a fundamental requirement for VPRN services and directly aligns with regulatory mandates for data privacy and security in telecommunications. The use of VRFs on PE routers ensures that routing information is kept separate for each customer, preventing route leaks and maintaining the integrity of the private network. This approach demonstrates best professional practice by prioritizing security and isolation, which are critical for meeting regulatory compliance and customer expectations for a private network service. Incorrect approaches analysis. One incorrect approach would be to implement the VPRN service by simply using separate VLAN on shared infrastructure without VRF segregation at the PE router level. This is a regulatory failure because it does not provide the necessary level of traffic isolation and security required for a VPRN. VLAN alone can be susceptible to misconfiguration or bridging attacks, potentially allowing traffic from one customer to be exposed to another, violating data privacy regulations. Another incorrect approach would be to configure all customer traffic within a single VRF on the PE routers, relying solely on access control lists, ACL, for separation. This is a significant regulatory and security failure. While ACLs can filter traffic, they do not provide the fundamental routing isolation that VRFs offer. A single VRF is inherently less secure and more prone to misconfiguration, which could lead to unintended traffic exposure or routing issues between customers, directly contravening the principles of secure VPRN service delivery and data protection mandates. Professional reasoning. Professionals tasked with implementing VPRN services must adopt a systematic approach that prioritizes regulatory compliance and security from the outset. This involves a thorough understanding of the VPRN architecture, specifically the role of VRFs in traffic isolation. The decision-making process should begin with a clear definition of the security and privacy requirements dictated by the relevant telecommunications regulations. Subsequently, the technical design must be evaluated against these requirements, ensuring that the chosen implementation method provides the necessary logical separation and prevents unauthorized access or interference between customer networks. Regular audits and testing of the VPRN implementation are also crucial to verify ongoing compliance and identify any potential vulnerabilities. Question 8. Quality control measures reveal unexpected and unauthorized routing entries appearing within a specific Alcatel Lucent Virtual Private Routed Network (VPRN) instance, potentially impacting traffic forwarding and security policies. What is the most appropriate initial course of action to address this anomaly? Option A. Disregard the anomalous entries as transient network noise, focusing on overall network performance metrics and assuming they will self-correct. Option B. Immediately isolate the affected VPRN instance using VPRN-specific commands. Analyze the anomalous routing entries against authorized configurations and network policies, and initiate a documented troubleshooting process to identify the root cause and implement corrective actions. Option C. Rely solely on external network monitoring alerts to diagnose the problem, without directly investigating the VPRN internal routing tables and configurations. Option D. Implement a broad rollback of recent configuration changes across the entire VPRN infrastructure to revert to a known stable state, assuming a recent deployment caused the issue. The correct answer is B. Immediately isolate the affected VPRN instance using VPRN-specific commands. Analyze the anomalous routing entries against authorized configurations and network policies, and initiate a documented troubleshooting process to identify the root cause and implement corrective actions. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in ensuring network security and compliance within a virtual private routed network (VPRN) environment. The core difficulty lies in balancing the need for efficient network operation and troubleshooting with the imperative to maintain strict access controls and data privacy, as mandated by regulatory frameworks governing telecommunications and data handling. The potential for misconfiguration or unauthorized access to sensitive routing information within a VPRN necessitates a rigorous and methodical approach to security audits and incident response. Correct approach analysis. The correct approach involves a systematic and documented investigation of the anomalous routing entries. This entails leveraging the Alcatel Lucent VPRN features to isolate the affected VPRN instance, analyze the specific routing table entries for discrepancies, and cross-reference these with established network policies and authorized configurations. The emphasis on using native VPRN diagnostic tools and adhering to established change management procedures ensures that any remediation actions are traceable, auditable, and minimize the risk of further network disruption or security compromise. This aligns with best professional practice by prioritizing data integrity, operational stability, and regulatory adherence through a controlled and evidence-based methodology. Correct approaches analysis. Implementing immediate, broad-stroke changes to the entire VPRN infrastructure without precise identification of the root cause is a significant regulatory and ethical failure. Such an approach risks disrupting legitimate traffic, violating service-level agreements, and potentially introducing new security vulnerabilities. It demonstrates a lack of due diligence and a failure to follow established incident response protocols, which are often implicitly or explicitly required by regulatory bodies to ensure network reliability and security. Ignoring the anomalous entries and assuming they are benign is another critical failure. This approach neglects the potential for a security breach, misconfiguration, or a subtle network issue that could escalate. It directly contravenes the professional responsibility to maintain network integrity and proactively address potential threats or anomalies, which is a cornerstone of regulatory compliance in the telecommunications sector. Relying solely on external network monitoring tools without validating the findings within the VPRN context is also professionally unacceptable. While external tools provide valuable insights, they may not fully grasp the intricacies of VPRN segmentation and routing policies. This can lead to misinterpretations, incorrect troubleshooting steps, and a failure to address the actual problem within the VPRN, thereby risking non-compliance with security and operational standards. Professional reasoning. Professionals facing such a situation should adopt a structured problem-solving framework. This begins with clear problem identification and scope definition. Next, gather all relevant data using appropriate diagnostic tools, prioritizing those native to the VPRN environment. Formulate hypotheses about the root cause and test them systematically. Implement changes in a controlled manner, following change management procedures, and thoroughly validate the resolution. Document all steps taken, findings, and resolutions for audit and future reference. This methodical approach ensures accountability, minimizes risk, and upholds professional standards and regulatory requirements. Question 9. The control framework reveals that a customer is experiencing intermittent packet loss on their virtual private routed network (VPRN) service. The network operations team needs to identify the root cause and restore service promptly. Which of the following diagnostic steps is the most appropriate initial action to take to ensure adherence to best practices for VPRN troubleshooting? Option A. Examine the utilization statistics of all network interfaces on the involved routers for signs of congestion. Option B. Verify the virtual routing instance (VRI) configuration, including interface assignments, routing protocol status within the VRI, and any associated policy configurations. Option C. Attempt to reset the VPRN interfaces on the customer's edge router to clear any potential temporary glitches. Option D. Immediately initiate a ping test from the customer's edge device to a known stable endpoint on the internet to assess general connectivity. The correct answer is B. Verify the virtual routing instance (VRI) configuration, including interface assignments, routing protocol status within the VRI, and any associated policy configurations. Explanation. The control framework reveals a critical juncture in managing a virtual private routed network (VPRN) service where a customer reports intermittent connectivity issues. This scenario is professionally challenging because it requires a rapid, accurate diagnosis within the constraints of a service level agreement (SLA), while adhering to the specific operational and security guidelines mandated by the 4A0-106 Alcatel Lucent Virtual Private Routed Networks Framework. The pressure to restore service quickly can lead to hasty decisions that might overlook underlying configuration or policy violations. The correct approach involves a systematic, evidence-based troubleshooting methodology that prioritizes verifying the integrity of the VPRN configuration and its adherence to the defined service parameters. This includes examining the virtual routing instance (VRI) configuration, ensuring correct interface assignments, verifying routing protocol adjacencies within the VPRN context, and confirming the absence of any policy conflicts that could lead to packet drops or misrouting. This methodical verification aligns with best professional practice by ensuring that the VPRN is configured and operating according to the established standards and customer requirements, thereby minimizing the risk of recurring issues and maintaining service quality. It also implicitly supports the operational integrity and security of the network by ensuring that the VPRN is not being exploited or misconfigured in a way that could impact other services. An incorrect approach of immediately assuming a physical layer issue without first validating the VPRN configuration is professionally unacceptable. This bypasses the essential step of verifying the logical service construct, which is the core of a VPRN. Such an approach risks misallocating resources, delaying the resolution of the actual problem, and potentially introducing further configuration errors if changes are made without a full understanding of the VPRN logical topology. It also fails to adhere to the structured troubleshooting processes expected within network operations, potentially violating internal operational guidelines and SLA commitments by not efficiently diagnosing the root cause. Another incorrect approach of solely relying on high-level network monitoring tools without delving into the VPRN-specific details is also problematic. While monitoring tools provide valuable insights, they may not always pinpoint VPRN-specific configuration anomalies or routing issues within the VRI. This superficial analysis can lead to a false sense of understanding and prolong the troubleshooting process, failing to address the unique characteristics of VPRN services as defined by the 4A0-106 framework. A third incorrect approach of making broad, unverified configuration changes across the network in an attempt to resolve the issue is highly risky. This violates the principle of least privilege and controlled change management. Such actions can have unintended consequences, impacting other services or creating new problems, and are a direct contravention of sound network engineering practices and the need for precise, targeted troubleshooting within a VPRN context. The professional decision-making process for similar situations should involve 1. Acknowledging the reported issue and its impact. 2. Consulting the VPRN service definition and associated SLAs. 3. Initiating a structured troubleshooting process that begins with verifying the VPRN logical configuration and routing state. 4. Utilizing VPRN-specific diagnostic tools and commands to gather evidence. 5. Implementing changes only after a clear hypothesis based on evidence has been formed and following a controlled change management process. 6. Documenting all steps taken and findings. Question 10. Benchmark analysis indicates a customer requires a private network solution connecting multiple geographically dispersed sites. The primary requirements are for guaranteed bandwidth between these sites and strict isolation of their traffic from other customers' traffic traversing the provider's network. The customer has expressed a preference for a solution that is operationally efficient for them to manage their internal routing, which Alcatel Lucent Virtual Private Routed Network (VPRN) approach best addresses these requirements. Option A. Implementing a VPLS solution to provide Layer 2 VPN connectivity. Option B. Establishing multiple ISEC VPN tunnels between each site. Option C. Configuring a standard IP routing solution without specific VPN technologies. Option D. Deploying GRE tunnels to encapsulate traffic between sites. Correct answer is A. Implementing a VPLS solution to provide Layer 2 VPN connectivity. Explanation. Scenario analysis. This scenario presents a common challenge in network design where a customer requires a private network solution that is both secure and cost-effective. The core of the challenge lies in balancing the need for isolation and guaranteed performance, often associated with MPLS VPNs, against the operational simplicity and broader reach of IP VPNs. The customer's stated requirement for guaranteed bandwidth and traffic isolation strongly suggests a need for a Layer 3 VPN solution that provides these characteristics. The professional challenge is to accurately interpret the customer's needs and map them to the most appropriate Alcatel Lucent Virtual Private Routed Network (VPRN) technology, considering the implications for scalability, management, and adherence to best practices within the regulatory framework governing network service provision. Correct approach analysis. Implementing a VPLS, Virtual Private LAN service, solution is the most appropriate approach. VPLS provides Layer 2 VPN connectivity, effectively extending a single Ethernet broadcast domain across multiple customer sites. This inherently offers traffic isolation at Layer 2, as traffic from one VPN does not traverse another. Furthermore, VPLS can be configured to support specific bandwidth allocations per customer or per service, addressing the guaranteed bandwidth requirement. From a regulatory and best practice perspective, VPLS aligns with the principle of providing a service that meets the stated technical and business requirements of the customer, ensuring a clear separation of traffic and predictable performance characteristics, which are often implicitly or explicitly covered by service-level agreements, SLAs, and general telecommunications regulations regarding service delivery and quality. Incorrect approaches analysis. Implementing a simple ISEC VPN tunnel between sites is an incorrect approach. While ISEC provides security through encryption and authentication, it operates at Layer 3 and does not inherently offer the traffic isolation or guaranteed bandwidth characteristics of a dedicated VPN service like VPLS or MPLS VPN. Each ISEC tunnel is point-to-point and does not provide the multi-point connectivity or the robust traffic engineering capabilities needed to guarantee bandwidth across a network. Ethically and regulatorily, this would fail to meet the customer's explicit requirements, potentially leading to SLA breaches and customer dissatisfaction. Implementing a GRE, generic routing encapsulation, tunnel is also an incorrect approach. GRE tunnels encapsulate network layer packets inside IP packets, providing a way to tunnel traffic across an IP network. However, GRE does not offer any inherent security, traffic isolation, or guaranteed bandwidth. It is primarily a tunneling protocol for extending network layer reachability. Relying on GRE for a requirement of guaranteed bandwidth and traffic isolation would be a significant failure to meet the customer's needs and would violate principles of responsible service provision. Implementing a simple IP routing solution without any VPN technology is fundamentally incorrect. This would mean all customer traffic would be routed over the provider's core network, without any form of isolation or guaranteed bandwidth. This would expose the customer's traffic to other customers and offer no control over performance, directly contradicting the stated requirements and any associated regulatory obligations for service segregation and quality. Professional reasoning. Professionals must first thoroughly understand the customer's stated and implied requirements. This involves active listening and asking clarifying questions about performance expectations, security needs, and scalability. Once requirements are understood, the professional must map these to the available technologies, considering their strengths and weaknesses. The decision should be driven by the technology that best meets the combination of requirements, not just a subset. In this case, the need for both guaranteed bandwidth and traffic isolation points towards a Layer 2 or Layer 3 VPN solution with advanced traffic management capabilities. Regulatory compliance and ethical considerations demand that the chosen solution accurately reflects the service promised to the customer and adheres to industry best practices for network service delivery. A failure to do so can result in contractual disputes, regulatory penalties, and damage to professional reputation. Question 11. Process analysis reveals that a critical business unit requires immediate deployment of a new application that generates highly sensitive data. This application needs to be accessible over the corporate network, but must be strictly isolated from all other traffic, including other VPRN services, to meet stringent data privacy regulations. The current VPRN infrastructure is configured with multiple VRFs for different business units, but there is no existing VRF specifically designed for this level of isolation and sensitivity. The business unit is pushing for a rapid deployment, citing urgent market demands. What is the most appropriate professional approach to address this requirement while adhering to VPRN best practices and regulatory considerations? Option A. Immediately configure the new application to use the existing management VRF, as it is the most secure and isolated VRF available, and inform the business unit that the deployment is complete. Option B. Design and implement a new, dedicated VRF within the existing VPRN infrastructure, ensuring it is configured with unique RDs and RTs, and apply strict ingress/egress ACLs to enforce complete traffic isolation, followed by a comprehensive security audit before service activation. Option C. Integrate the new application's traffic into an existing VRF that serves a less sensitive business unit, assuming the current VRF has sufficient capacity and can be reconfigured with minor adjustments. Option D. Advise the business unit that the current VPRN infrastructure is not capable of meeting their stringent isolation requirements, and recommend they explore alternative, out-of-band network solutions, without proposing any modifications to the existing VPRN. Correct answer is B. Design and implement a new, dedicated VRF within the existing VPRN infrastructure, ensuring it is configured with unique RDs and RTs, and apply strict ingress/egress ACLs to enforce complete traffic isolation, followed by a comprehensive security audit before service activation. Explanation. Scenario analysis. This scenario presents a common challenge in network design and implementation, where a new service requirement directly conflicts with existing network security policies and the operational capabilities of the current virtual private routed network, VPRN, infrastructure. The professional challenge lies in balancing the business need for rapid service deployment with the imperative to maintain network integrity, security, and compliance with established Alcatel Lucent VPRN best practices, and any implicit or explicit regulatory guidelines that govern network segmentation and traffic isolation. The need for a quick resolution without compromising security or performance adds significant pressure. Correct approach analysis. The correct approach involves a thorough assessment of the VPRN capabilities and limitations in relation to the new service's traffic patterns and security requirements. This includes verifying if the existing VPRN configuration can accommodate the new service's traffic isolation needs through appropriate VRF, virtual routing and forwarding, instance configuration, route distinguisher RD, and route target RT manipulation, and access control list ACL implementation. If the existing VPRN cannot meet the new requirements without compromising security or performance, the best professional practice is to propose a phased approach. First, conduct a detailed impact analysis, then design and implement a dedicated VPRN or a segregated VRF within the existing VPRN, ensuring all security policies and isolation requirements are met. This aligns with the principle of least privilege and robust network segmentation, which are fundamental to secure VPRN deployments as outlined in Alcatel Lucent VPRN design principles and operational guides. Adhering to these principles ensures that the new service does not inadvertently expose sensitive data or create security vulnerabilities. Incorrect approaches analysis. One incorrect approach is to immediately attempt to integrate the new service into an existing VRF without verifying its security and isolation requirements. This failure constitutes a significant regulatory and ethical lapse, as it bypasses established security protocols and potentially violates data privacy or compliance mandates that require strict traffic segregation. It demonstrates a disregard for the fundamental purpose of VPRN in providing secure, isolated private networks. Another incorrect approach is to delay the service deployment indefinitely due to perceived complexity, without proposing alternative solutions or engaging in a structured problem-solving process. This failure represents a lack of proactive problem-solving and can lead to business dissatisfaction and potential loss of revenue, indicating a deficiency in professional responsibility to meet business needs within operational constraints. A third incorrect approach is to implement a quick, ad hoc solution that bypasses standard change control and security review processes. This is a critical regulatory and ethical failure, as it introduces unvetted changes into the network, increasing the risk of misconfiguration, security breaches, and service disruptions. It undermines the integrity of the network management framework and demonstrates a lack of adherence to operational best practices and potential compliance requirements for network change management. Professional reasoning. Professionals should adopt a structured, risk-based decision-making process. This involves 1. Understanding the business requirement and its technical implications. 2. Assessing the current network state and its capabilities against the new requirement. 3. Identifying potential risks and compliance gaps. 4. Developing and evaluating multiple solutions, considering security, performance, scalability, and cost. 5. Selecting the solution that best balances business needs with operational integrity and compliance. 6. Documenting the decision-making process and the chosen solution. 7. Implementing the solution, following established change management and testing procedures. Question 12. Assessment of the process for ensuring Alcatel Lucent VPRN deployments in the specified jurisdiction comply with all relevant telecommunications and data privacy regulations, considering the potential for technical configurations to inadvertently violate legal mandates. Option A. Relying on general industry best practices for VPRN security and privacy, without specific verification against the detailed legal and regulatory obligations of the jurisdiction. Option B. Implementing a VPRN solution based on vendor-recommended configurations and assuming these align with local regulatory requirements, with compliance verification deferred to a post-deployment audit. Option C. Conducting a thorough review of the specific regulatory framework for the jurisdiction, mapping VPRN design elements and operational procedures against each requirement, and obtaining formal sign-off from compliance stakeholders before proceeding with deployment. Option D. Prioritizing rapid deployment of VPRN services to meet market demand, with a plan to address any potential regulatory issues that may arise after the service is operational. The correct answer is B. Implementing a VPRN solution based on vendor-recommended configurations and assuming these align with local regulatory requirements, with compliance verification deferred to a post-deployment audit. Explanation. Scenario analysis. This scenario presents a professional challenge in ensuring that the implementation of Alcatel Lucent Virtual Private Routed Networks, VPRN, adheres strictly to the regulatory framework governing telecommunication services within the specified jurisdiction. The core difficulty lies in the potential for misinterpretation or oversight of specific regulatory clauses related to service provisioning, data privacy, and network security when deploying complex VPRN solutions. Professionals must navigate the technical intricacies of VPRN configuration while maintaining a vigilant focus on compliance, as deviations can lead to significant legal penalties, reputational damage, and service disruption for customers. The dynamic nature of regulatory updates further complicates this, requiring continuous learning and adaptation. Correct approach analysis. The correct approach involves a proactive and documented process of regulatory review and validation. This entails consulting the official regulatory documentation for the specified jurisdiction, e.g., relevant telecommunications acts, data protection laws, and specific guidelines issued by the regulatory body at the design and implementation phases. A key aspect is to map VPRN features and operational procedures directly against these regulatory requirements. For instance, if regulations mandate specific data handling protocols or security measures for private networks, the VPRN design must explicitly incorporate these. Documenting this mapping and obtaining formal sign-off from compliance officers or legal counsel before deployment demonstrates due diligence and adherence to the regulatory framework. This approach ensures that the VPRN is not only technically sound, but also legally compliant, safeguarding the organization and its customers. Incorrect approaches analysis. One incorrect approach is to assume that standard VPRN best practices inherently satisfy all regulatory obligations. This is a failure because regulatory frameworks are jurisdiction-specific and may impose requirements beyond general industry standards, such as unique data localization mandates or specific encryption key management procedures. Relying solely on best practices without explicit regulatory verification is a direct contravention of the principle of adhering to the specified legal framework. Another incorrect approach is to defer regulatory compliance checks to the post-implementation audit phase. This is problematic as it risks discovering noncompliance only after significant investment and deployment, leading to costly remediation efforts, potential service interruptions, and regulatory sanctions. The regulatory framework typically expects compliance to be built into the design and deployment process, not treated as an afterthought. A third incorrect approach is to rely on informal verbal assurances from technical teams or vendors regarding compliance without seeking documented evidence or formal validation against the specific regulatory requirements. This lacks the rigor demanded by regulatory bodies and leaves the organization vulnerable to claims of negligence. Professional practice dictates that compliance must be verifiable and documented. Professional reasoning. Professionals should adopt a risk-based approach to regulatory compliance. This involves identifying all applicable regulations for the jurisdiction, understanding their implications for VPRN deployment, and implementing controls to ensure adherence. A structured process of design review, implementation verification, and ongoing monitoring, all supported by thorough documentation, is essential. When faced with ambiguity, seeking clarification from regulatory bodies or legal experts is a critical step. The decision-making process should prioritize proactive compliance over reactive remediation, ensuring that technical solutions are always aligned with legal and ethical obligations. Question 13. Comparative studies suggest that the implementation of virtual private routed networks, VPRN, can significantly enhance network security and data segregation. Considering the Alcatel Lucent 4A0-106 syllabus and the imperative for regulatory compliance, which of the following approaches best ensures that a VPRN deployment adheres to data privacy and access control mandates? Option A. Prioritizing network performance optimization over any security configurations within the VPRN. Option B. Configuring VPRN with explicit VRF instances for each customer or department and applying granular access control lists, ACL, to VPRN interfaces to restrict traffic flow based on defined security policies. Option C. Assuming that standard IP routing protocols inherently provide sufficient security for private routed networks. Option D. Relying solely on the inherent logical separation provided by VPRN technology without specific security policy enforcement. The correct answer is D. Relying solely on the inherent logical separation provided by VPRN technology without specific security policy enforcement. Explanation. Scenario analysis. This scenario presents a professional challenge in network design and implementation where the primary objective is to ensure the secure and compliant operation of virtual private routed networks, VPRN, within the Alcatel Lucent ecosystem, adhering strictly to the 4A0-106 syllabus. The challenge lies in balancing the technical requirements of VPRN deployment with the overarching regulatory framework governing network security and data privacy. Misinterpreting or overlooking specific regulatory mandates can lead to significant compliance breaches, data exposure, and operational disruptions. The need for deep understanding of how VPRN features interact with regulatory controls is paramount. Correct approach analysis. The correct approach involves a thorough understanding of how Alcatel Lucent VPRN features, as detailed in the 4A0-106 syllabus, can be configured and managed to meet specific regulatory requirements for data segregation and access control. This includes leveraging VPRN capabilities like VRF, virtual routing and forwarding, instances to isolate traffic for different customers or departments, thereby enforcing logical separation as often mandated by data privacy regulations. Furthermore, understanding how VPRN interfaces with security policies, such as access control lists, ACL, applied at the VPRN level, is crucial for ensuring that only authorized traffic traverses the private network. This approach aligns with the principle of security by design, where regulatory compliance is integrated into the network architecture from the outset, minimizing the risk of future remediation and ensuring adherence to the spirit and letter of relevant regulations. Incorrect approach is analysis. An incorrect approach would be to assume that the inherent isolation provided by VPRN technology is sufficient without explicit configuration and verification against regulatory mandates. For instance, Failing to implement granular access controls within a VPRN, or not properly segmenting traffic between different security zones, could lead to unauthorized access or data leakage, violating principles of data protection and network security. Another failure would be to overlook the importance of logging and auditing VPRN traffic and configuration changes. Many regulations require comprehensive audit trails to demonstrate compliance and facilitate incident response. Neglecting this aspect leaves an organization vulnerable to undetected breaches and unable to prove adherence to oversight bodies. Finally, a common pitfall is to treat VPRN configuration as purely a technical exercise, divorced from the business and regulatory context. This can result in a network that is technically functional but fails to meet the specific security and privacy obligations of the organization, leading to non-compliance. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing the identification of regulatory requirements that directly impact VPRN design and operation. This involves consulting relevant regulatory documentation and understanding how VPRN features can be mapped to these requirements. A systematic process of design, implementation, testing, and ongoing monitoring is essential. This includes 1. Requirement gathering. Clearly define all applicable regulatory obligations related to data privacy, security, and network segregation. 2. VPRN design mapping. Determine how VPRN features e.g. VRF routing policies, CoS security policies can be configured to meet these requirements. 3. Implementation and configuration. Apply configurations meticulously, ensuring adherence to best practices and documented procedures. 4. Verification and testing. Conduct thorough testing to validate that the VPRN operates as intended and meets all compliance objectives. 5. Auditing and monitoring. Establish continuous monitoring and regular auditing of VPRN configurations and traffic to detect and address any deviations from compliance. Question 14. The assessment process reveals that a network engineering team is designing a VPRN service for a critical infrastructure client. While the team has extensive experience with Alcatel Lucent VPRN technologies and adheres to general industry best practices for network security and performance, they have not explicitly cross-referenced their design against the specific regulatory framework governing VPRN in the jurisdiction of operation. Which of the following actions is the most critical step to ensure regulatory compliance for this VPRN deployment? Option A. Seek informal advice from senior network engineers within the organization regarding general compliance, without consulting official regulatory documentation. Option B. Prioritize the client's immediate technical requirements and performance expectations, deferring any regulatory compliance checks until after the service is fully operational. Option C. Conduct a comprehensive review of the jurisdiction's telecommunications regulations and guidelines specifically pertaining to VPRN services, and map each requirement to the proposed VPRN design and operational procedures. Option D. Rely on the established industry best practices for VPRN security and performance, assuming they implicitly satisfy all regulatory obligations. The correct answer is C. Conduct a comprehensive review of the jurisdiction's telecommunications regulations and guidelines specifically pertaining to VPRN services, and map each requirement to the proposed VPRN design and operational procedures. Explanation. The assessment process reveals a common challenge in network deployments, ensuring that the implementation of virtual private routed networks, VPRN, adheres strictly to the regulatory framework governing telecommunications services within the specified jurisdiction. This scenario is professionally challenging because a misinterpretation or oversight of these regulations can lead to noncompliance, resulting in significant penalties, service disruptions, and reputational damage. The core of the challenge lies in translating abstract regulatory requirements into concrete network design and operational practices. The correct approach represents best professional practice because it prioritizes a thorough understanding and direct application of the relevant regulatory framework. Specifically, it involves consulting and interpreting the official documentation for the 4A0-106 Alcatel Lucent Virtual Private Routed Network syllabus, which implicitly guides adherence to the underlying regulatory principles for VPRN in the designated jurisdiction. This ensures that the VPRN implementation meets all legal and operational mandates, such as data privacy, security, and service-level agreements as defined by the regulatory body. This proactive and compliant approach minimizes risk and builds trust with both regulators and customers. An incorrect approach that focuses solely on technical best practices without explicit consideration of the regulatory framework is professionally unacceptable. This failure stems from a lack of due diligence regarding legal obligations. For instance, implementing a VPRN with security measures that, while technically sound, do not meet specific data protection mandates outlined in the jurisdiction's telecommunications laws constitutes a regulatory failure. Another incorrect approach might involve assuming that common industry standards for VPRN are sufficient, without verifying their alignment with the specific regulatory requirements. This can lead to overlooking unique local mandates, such as specific reporting obligations or customer notification procedures, resulting in ethical and legal breaches. The professional decision-making process for similar situations should involve a multi-stage approach. First, identify and obtain all relevant regulatory documents and guidelines pertaining to VPRN within the specified jurisdiction. Second, conduct a detailed review of these documents to understand all mandates, restrictions, and requirements. Third, map these regulatory requirements directly to the technical design and operational procedures for the VPRN implementation. Fourth, seek expert legal or compliance advice if any aspect of the regulations is unclear or ambiguous. Finally, document all compliance efforts and maintain ongoing monitoring to ensure continued adherence to the regulatory framework. Question 15. To address the challenge of ensuring a newly deployed Alcatel Lucent VPRN service adheres to the specific data privacy and security regulations mandated by the relevant jurisdiction, which of the following actions is the most critical initial step for the network engineering team? Option A. Prioritize the deployment timeline and budget, making regulatory compliance a secondary consideration to be addressed after the VPRN is fully operational. Option B. Conduct a comprehensive review of the VPRN design to identify all potential points of data ingress and egress, and map these to the specific data protection requirements stipulated by the applicable regulatory framework. Option C. Rely on the VPRN service provider's standard compliance documentation, assuming their solution meets all local regulatory mandates without independent verification. Option D. Proceed with the VPRN implementation based on industry best practices for network security, assuming that these practices inherently satisfy all regulatory obligations. The correct answer is B. Conduct a comprehensive review of the VPRN design to identify all potential points of data ingress and egress, and map these to the specific data protection requirements stipulated by the applicable regulatory framework. Explanation. The scenario presents a common challenge in network deployment, ensuring compliance with evolving regulatory requirements for data privacy and security within a virtual private routed network (VPRN) environment. The professional challenge lies in balancing the technical implementation of VPRN services with the imperative to adhere to specific, often nuanced, regulatory mandates without compromising network functionality or security. This requires a proactive and informed approach to network design and ongoing management. The correct approach represents best professional practice because it prioritizes a thorough understanding of the applicable regulatory framework before and during the VPRN implementation. Specifically, it involves engaging with legal and compliance teams to interpret and apply the relevant data privacy and security regulations to the VPRN architecture. This ensures that technical decisions are informed by legal obligations, mitigating the risk of noncompliance, data breaches, and subsequent penalties. It demonstrates a commitment to responsible network engineering and data stewardship. An incorrect approach that focuses solely on technical feasibility without considering regulatory implications is professionally unacceptable. This failure stems from a lack of due diligence regarding legal obligations, potentially leading to the deployment of a VPRN that inadvertently violates data privacy laws. Such a failure could result in significant financial penalties, reputational damage, and loss of customer trust. Another incorrect approach that relies on assumptions about regulatory compliance without explicit verification is equally problematic. Assumptions, especially in the sensitive area of data privacy, can lead to critical oversights. This approach demonstrates a lack of rigor and a failure to engage with the necessary expertise to ensure adherence to legal standards. A third incorrect approach that prioritizes cost saving over regulatory adherence is a direct violation of professional ethics and legal requirements. While cost efficiency is important, it can never supersede the legal obligation to protect sensitive data and comply with privacy regulations. This approach indicates a disregard for legal and ethical responsibilities, exposing the organization to severe consequences. The professional decision-making process for similar situations should involve a multidisciplinary approach. Network engineers must actively seek to understand the regulatory landscape relevant to their deployments. This includes consulting with legal counsel, compliance officers, and security experts. A risk-based assessment should be conducted, identifying potential regulatory pitfalls and developing mitigation strategies. Continuous monitoring and periodic reviews of the VPRN configuration against updated regulations are also crucial for sustained compliance. Question 16. Stakeholder feedback indicates a need to enhance network segmentation and security for sensitive customer data by implementing Alcatel Lucent Virtual Private Routed Networks, VPRN. Before proceeding with the technical design and deployment of these VPRN, what is the most appropriate regulatory compliance approach to ensure adherence to data protection laws within the specified jurisdiction? Option A. Conduct a comprehensive data protection impact assessment, DPIA, in consultation with legal and compliance teams to identify and mitigate any risks to personal data processing posed by the VPRN implementation, and obtain formal approval before proceeding. Option B. Initiate the VPRN deployment immediately to address the urgent need for segmentation and address any potential regulatory compliance issues retrospectively as they arise. Option C. Rely on the existing network security policies, which are assumed to be compliant with all relevant data protection laws, without conducting a specific review for the VPRN implementation. Option D. Proceed with the VPRN deployment using the vendor's recommended security configurations, assuming they meet general industry best practices for data security. Correct answer is A. Conduct a comprehensive data protection impact assessment, DPIA, in consultation with legal and compliance teams to identify and mitigate any risks to personal data processing posed by the VPRN implementation, and obtain formal approval before proceeding. Explanation. This scenario presents a professional challenge due to the inherent tension between implementing advanced network technologies like Alcatel Lucent Virtual Private Routed Networks, VPRN, and ensuring strict adherence to regulatory compliance, specifically concerning data privacy and security, as mandated by the relevant jurisdiction's data protection laws. The need to balance technological innovation with legal obligations requires careful consideration of how VPRN configurations impact data handling and access. The correct approach represents best professional practice because it prioritizes a proactive and documented assessment of regulatory compliance before and during VPRN deployment. This involves engaging with legal and compliance teams to ensure that the VPRN design and operational procedures align with data privacy regulations, such as those governing the lawful processing of personal data, data minimization, and the implementation of appropriate security measures to protect data in transit and at rest. This aligns with the principle of privacy by design and privacy by default, which are fundamental to modern data protection frameworks. By conducting a thorough impact assessment and obtaining explicit approvals, the network engineer demonstrates due diligence and a commitment to operating within legal boundaries, thereby mitigating risks of non-compliance, fines, and reputational damage. An incorrect approach that overlooks the regulatory implications of VPRN implementation is professionally unacceptable. Specifically, proceeding with deployment without a formal review by legal and compliance departments represents a failure to adhere to established corporate governance and regulatory oversight processes. This can lead to significant regulatory or ethical failures, such as potential breaches of data privacy laws if sensitive data is inadvertently exposed or mishandled due to inadequate VPRN segmentation or access controls. Another incorrect approach, such as relying solely on vendor default security settings without a specific compliance review, is also problematic. This demonstrates a lack of critical assessment and an abdication of responsibility to ensure that the technology meets the specific legal requirements of the operating jurisdiction, potentially leading to non-compliance with data protection principles like accountability and security. The professional decision-making process for similar situations should involve a structured risk assessment framework. This framework should include identifying all relevant regulatory requirements, understanding how the proposed technology, in this case VPRN, interacts with these requirements, consulting with legal, compliance, and security experts, documenting all assessments, decisions, and mitigation strategies, and obtaining formal sign-off before proceeding with implementation. Professionals must cultivate a mindset of proactive compliance, viewing regulatory requirements not as obstacles, but as integral components of sound network design and operation. Question 17. The monitoring system demonstrates an unusual pattern of high resource utilization on a core router responsible for multiple VPRN services. To diagnose the issue, the network operations team is considering several approaches to investigate the traffic. Which approach best aligns with regulatory compliance and professional data handling practices for VPRN services? Option A. Temporarily disable VPRN services for affected customers to isolate the issue without prior notification to reduce the volume of traffic being monitored. Option B. Rely on the default monitoring configurations provided by the router vendor, assuming they are compliant with all relevant data protection regulations. Option C. Configure the monitoring system to collect and analyze traffic flow data, including source/destination IP addresses, port numbers, and packet/byte counts, while anonymizing or excluding payload content. Option D. Implement Deep Packet Inspection, DPI, on all VPRN traffic flows to capture and analyze the full packet payload for anomalies. The correct answer is D. Implement Deep Packet Inspection, DPI, on all VPRN traffic flows to capture and analyze the full packet payload for anomalies. Explanation. This scenario presents a professional challenge because it requires network engineers to balance the technical requirements of ensuring virtual private routed network, VPRN, service integrity with the regulatory obligations for data privacy and security. The core difficulty lies in distinguishing between legitimate network monitoring activities and those that could inadvertently compromise sensitive customer data, especially when dealing with traffic that may contain personally identifiable information, PI, or other confidential data. Careful judgment is required to implement monitoring solutions that are both effective for troubleshooting and compliant with data protection regulations. The correct approach represents best professional practice because it prioritizes data minimization and anonymization during network monitoring. By focusing on metadata, traffic flow patterns, and aggregated statistics rather than the content of customer traffic, it adheres to the principle of least privilege in data protection by design. This aligns with regulatory frameworks that mandate the protection of customer data and limit access to sensitive information. Specifically, it respects the spirit of regulations that require data to be processed only for specified, legitimate purposes and to the extent necessary. An incorrect approach that involves capturing and analyzing the full payload of customer traffic for troubleshooting purposes represents a significant regulatory and ethical failure. This would likely violate data privacy laws by indiscriminately accessing and processing sensitive customer information without explicit consent or a clear legal basis. Such an action could lead to severe penalties, reputational damage, and a breach of trust with customers. Another incorrect approach, such as relying solely on vendor-provided default monitoring configurations without a thorough review for compliance, is also professionally unacceptable. This demonstrates a lack of due diligence and a failure to proactively identify and mitigate potential data privacy risks inherent in network operations. Professionals should employ a decision-making framework that begins with understanding the specific regulatory requirements applicable to their operating jurisdiction concerning data privacy and network monitoring. This should be followed by a risk assessment to identify potential data privacy exposures in proposed monitoring strategies. Implementing a layered approach to monitoring, starting with less intrusive methods and escalating only when necessary and with appropriate safeguards, is crucial. Furthermore, continuous training on data protection, best practices, and regular audits of monitoring practices are essential to maintain compliance and ethical standards. Question 18. The efficiency study reveals that a telecommunications provider is experiencing increased scrutiny from regulatory bodies regarding the security and isolation of their virtual private routed networks, VPRN services. Specifically, auditors are questioning whether the current VPRN implementation adequately segregates customer traffic and prevents unauthorized access, as mandated by the relevant data protection and network security regulations. The provider needs to demonstrate a robust approach to ensuring compliance. Which of the following actions best addresses the regulatory concerns and ensures ongoing compliance for the VPRN deployments? Option A. Implementing a comprehensive, documented VPRN deployment and configuration policy that explicitly maps VPRN features and operational procedures to specific regulatory requirements, and conducting regular internal audits against this policy. Option B. Relying on the inherent security features of the VPRN technology as described in vendor documentation, assuming these are sufficient to meet all regulatory obligations. Option C. Updating the VPRN configuration to the latest vendor release without a specific review of how the new features impact existing regulatory compliance. Option D. Deferring any significant changes to VPRN configurations until a formal regulatory audit is completed, to avoid potential misinterpretations of current requirements. The correct answer is A. Implementing a comprehensive, documented VPRN deployment and configuration policy that explicitly maps VPRN features and operational procedures to specific regulatory requirements, and conducting regular internal audits against this policy. Explanation. The efficiency study reveals a potential discrepancy in how Alcatel Lucent virtual private routed networks, VPRN, are being configured to meet regulatory compliance requirements. The challenge lies in balancing the technical implementation of VPRN services with the stringent, often evolving regulatory mandates that govern data privacy, security, and network integrity. Professionals must demonstrate a deep understanding of both the technical capabilities of VPRN and the specific legal and regulatory frameworks applicable to their operating jurisdiction. The correct approach involves a proactive and documented process of aligning VPRN configurations with all relevant regulatory requirements. This means not only understanding the technical specifications of VPRN, but also actively researching, interpreting, and applying the specific laws and guidelines that dictate how private networks must be secured, how data must be protected, and how network access is controlled. This approach represents best professional practice because it ensures that the deployed VPRN services are not only technically sound, but also legally compliant, thereby mitigating risks of fines, reputational damage, and service disruption. It demonstrates due diligence and a commitment to operating within the established legal and ethical boundaries. An incorrect approach would be to assume that standard VPRN configurations inherently satisfy all regulatory needs. This is a failure to acknowledge the specific and often unique demands of regulatory frameworks. For instance, a configuration that might be technically efficient for routing could fail to implement the necessary encryption standards or access control lists mandated by data protection laws, leading to a regulatory or ethical failure. Another incorrect approach is to prioritize cost-saving or speed of deployment over thorough regulatory review. This can result in non-compliance, which carries significant penalties and can undermine customer trust. A third incorrect approach is to rely on outdated or incomplete regulatory knowledge. Regulations change, and a failure to stay current can lead to inadvertent breaches of compliance, representing a significant professional and ethical lapse. Professionals should adopt a decision-making process that begins with a comprehensive understanding of the applicable regulatory landscape for VPRN deployments. This involves consulting official regulatory documents, seeking legal counsel when necessary, and integrating compliance checks into the design and implementation phases of VPRN services. Regular audits and reviews of configurations against current regulations are crucial. When faced with ambiguity, the professional approach is to err on the side of caution, seek clarification, and document all decisions and their justifications. Question 19. Consider a scenario where a telecommunications provider is planning to deploy Alcatel Lucent Virtual Private Routed Networks, VPRN, to offer secure connectivity services to its enterprise customers. The project team is focused on the technical configuration and service provisioning aspects. What is the most critical step that must be undertaken before proceeding with the full deployment to ensure regulatory compliance and operational security? Option A. Prioritize the immediate deployment to meet market demand, with a plan to address security concerns retrospectively as they arise. Option B. Proceed with the deployment based on the assumption that the Alcatel Lucent VPRN technology inherently provides sufficient security for all use cases. Option C. Rely exclusively on the security features and recommendations provided by the Alcatel Lucent vendor without conducting an independent assessment. Option D. Conduct a comprehensive risk assessment to identify potential threats, vulnerabilities, and their impact on the VPRN infrastructure and customer data, and develop mitigation strategies. Correct answer is D. Conduct a comprehensive risk assessment to identify potential threats, vulnerabilities, and their impact on the VPRN infrastructure and customer data, and develop mitigation strategies. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of virtual private routed networks, VPRN, and the critical need for robust risk assessment in a regulated environment. The challenge lies in balancing the operational benefits of VPRN, such as efficient resource utilization and secure private connectivity, with the potential security vulnerabilities and compliance risks they introduce. A failure to adequately assess and mitigate these risks can lead to data breaches, service disruptions, and non-compliance with regulatory mandates, all of which carry significant financial and reputational consequences. The specific context of Alcatel Lucent VPRN technology, while not dictating a different regulatory framework, implies a need for understanding its specific features and potential risk vectors within the broader regulatory landscape. Correct approach analysis. The correct approach involves a systematic and comprehensive risk assessment process that is aligned with the regulatory framework governing telecommunications and data security. This process should identify potential threats to the VPRN infrastructure, analyze the vulnerabilities that could be exploited, and evaluate the likelihood and impact of such events. Based on this analysis, appropriate mitigation strategies should be developed and implemented. This proactive and structured approach ensures that security controls are proportionate to the identified risks, and that the VPRN deployment adheres to all relevant regulatory requirements, such as those pertaining to data privacy, network resilience, and service availability. It demonstrates due diligence and a commitment to maintaining a secure and compliant network environment. Incorrect approaches analysis. Implementing VPRN without a formal risk assessment is a significant regulatory and ethical failure. It demonstrates a lack of due diligence and a disregard for potential security threats and compliance obligations. This approach can lead to the deployment of a network that is inherently vulnerable, potentially exposing sensitive data and leading to service disruptions, which would violate regulations mandating data protection and service continuity. Focusing solely on the technical implementation and operational efficiency of VPRN, while neglecting the associated risks, is another failure. This narrow focus overlooks the broader implications of network security and compliance. It can result in security gaps that are not identified or addressed, leaving the organization exposed to cyber threats and regulatory penalties for non-compliance with security standards. Relying on vendor-provided security features as a complete solution without independent risk assessment is also problematic. While vendors offer security capabilities, they are not a substitute for an organization's own risk assessment process. This approach fails to account for the specific operational context, unique threat landscape, and specific regulatory requirements of the deploying organization. It can lead to a false sense of security and leave critical vulnerabilities unaddressed, violating the principle of responsible network management and regulatory adherence. Professional reasoning. Professionals should approach VPRN deployment with a risk-based mindset. The decision-making process should begin with understanding the regulatory landscape and its implications for network security and data privacy. This should be followed by a thorough risk assessment that identifies, analyzes, and prioritizes potential threats and vulnerabilities specific to the VPRN implementation. Mitigation strategies should then be developed and integrated into the network design and operational procedures. Continuous monitoring and periodic reassessment of risks are crucial to adapt to evolving threats and regulatory changes. This systematic and proactive approach ensures that the VPRN provides the intended business benefits while maintaining a high level of security and compliance. Question 20. The investigation demonstrates that a critical vulnerability has been identified within the core routing software of an Alcatel Lucent VPRN deployment. The network engineering team is under significant pressure to restore full-service functionality to affected customers immediately. Given the urgency, what is the most appropriate course of action to address this vulnerability? Option A. Conduct a comprehensive risk assessment to identify the potential impact of the vulnerability on the VPRN, prioritize threats, and develop a targeted mitigation strategy. Option B. Prioritize the implementation of a solution that minimizes immediate expenditure, even if it does not fully address the underlying security risk. Option C. Document the vulnerability and monitor for any signs of exploitation, deferring remediation until a more convenient time. Option D. Immediately deploy a vendor-provided patch for the vulnerability without further testing, prioritizing speed of resolution. The correct answer is A. Conduct a comprehensive risk assessment to identify the potential impact of the vulnerability on the VPRN, prioritize threats, and develop a targeted mitigation strategy. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a network engineer to balance the immediate need for service restoration with the long-term implications of security vulnerabilities. The pressure to restore connectivity quickly can lead to shortcuts that compromise the integrity of the virtual private routed network, VPRN, and potentially expose sensitive data. The engineer must exercise careful judgment to ensure that any remediation actions are both effective and compliant with established security policies and best practices, as outlined by the relevant regulatory framework for Alcatel Lucent VPRN deployments. The absence of a formal risk assessment process exacerbates this challenge, leaving the decision-making process susceptible to ad hoc and potentially inadequate solutions. Correct approach analysis. The correct approach involves conducting a thorough risk assessment to identify, analyze, and evaluate the potential impact of the identified vulnerability on the VPRN. This process should prioritize threats based on their likelihood and potential severity, considering factors such as data confidentiality, integrity, and availability. By systematically assessing the risks, the engineer can then develop and implement mitigation strategies that are proportionate to the identified threats. This aligns with best professional practice by ensuring that security decisions are data-driven and aligned with the organization's overall risk appetite. Regulatory frameworks often mandate such proactive risk management to maintain the security and reliability of network infrastructure, especially for sensitive VPRN services. Incorrect approaches analysis. Implementing an immediate, unverified patch without a risk assessment is professionally unacceptable because it bypasses critical security validation. This could introduce new vulnerabilities, destabilize the VPRN, or fail to address the root cause, leading to a false sense of security. Ethically and regulatorily, this approach demonstrates a failure to adhere to due diligence and potentially violates guidelines that require documented security assessments before deploying changes to critical infrastructure. Ignoring the vulnerability due to the perceived low likelihood of exploitation is also professionally unsound. This approach neglects the principle of defense in depth and assumes a static threat landscape, which is rarely the case. Regulatory frameworks often emphasize a proactive stance against potential threats, and ignoring a known vulnerability, regardless of perceived likelihood, can be seen as negligence, especially if it leads to a breach. Focusing solely on the cost of remediation without considering the potential impact of a successful exploit is a flawed approach. While cost is a factor, it should not override the imperative to protect sensitive data and maintain service availability. A comprehensive risk assessment inherently balances the cost of mitigation against the potential cost of a security incident, which can include financial losses, reputational damage, and regulatory penalties. Failing to do so is a failure of professional responsibility and potentially a breach of regulatory compliance. Professional reasoning. Professionals should adopt a structured decision-making process that begins with understanding the problem and its potential impact. This involves gathering all relevant information about the vulnerability and the VPRN environment. The next step is to identify potential solutions and, crucially, to evaluate each solution through a formal risk assessment framework. This framework should consider the likelihood of threats, the potential impact of those threats, and the effectiveness and feasibility of proposed mitigation strategies. Decisions should be documented, and the chosen course of action should be the one that best mitigates identified risks while adhering to regulatory requirements and organizational policies. Regular review and reassessment of risks are also vital components of this process.